Hi, Math 1, Mr. Brunt here. We are going to look at a few examples for working with exponential functions. Our first example here says that we have a new company stock that has been growing such that it doubles in value each year with an initial stock price of $3 per share. What will be its value in 5 years? So remember, our exponential functions are always something of the form y equals a times b to the x. We have a starting value in all of this, and a represents my starting value, my y-intercept. In this case, since we were told that the initial price of the stock is $3 per share, we can say our a value is 3. And then we want to talk about how is this growing each year. And since the problem tells us that it doubles every year, doubling means we are multiplying by 2 each year. So our multiplier is 2, and with those 2 pieces of information, we can now write our equation of y equals 3 times 2 to the x. In this case, figuring out what does y represent, what does x represent in the context of this problem, our x value is often measured in time. So x is going to be, in this case, years. This is how many years have passed since the stock was offered. And then y is going to be what's the current value of that stock. So if I wanted to find out what's the value at 0 years, if I plugged in 0 for x, I could say y equals 3 times 2 to the 0, but we remember that anything to the 0 power is 1. So really this is 3 times 1, so our value was 3. But we already knew that. We already knew that at time 0, we had a initial value of 3. And so our question is, what's the value at time t equal 5 years? So we're going to say, what happens when your x value is 5? So y is going to be 3 times 2 to the 5th. And so this is 2 to the 5th. Remember, 2 to the 5th means 2 times 2 times 2 times 2 times 2, 5 times. 32. And now I have a 3 times 32. And the value of this stock is going to be $96 per share. Okay? So that's how we're using this exponential function to figure out what's the value of that stock, what's the price of that stock after 5 years. All right, so let's look at a different example here. In this case, we're going to deal with a depreciation. So that's something that is losing value. In this case, I'm telling you that we have a new truck. The new truck costs $40,000. However, it loses 12% of its value each year. So what will it be worth in 7 years? So right off the bat, I am going to think again, this is probably some sort of exponential function. So I can write out, it's probably going to look like y equals a times b to the x. There's something that jumps out to me here. It's a new truck value of $40,000. That's my initial amount. That's my starting value. So we're going to have an a value of 40,000. Great, I figured that out. So coming up with the b is going to be a little bit trickier. I think some students are tempted to think that our multiplier will be 12%. If we're dealing with percents, we'll change that into a decimal, call it 0.12. However, we're not taking 12% of the 40,000. What's really happening is I lose whatever 12% of that value is. So essentially, if I'm going from year 0 to year 1, year 0, my truck had a price of $40,000, and then I lose 12% of that $40,000. So lose 0.12 times the 40,000. And I could work on my calculator to try to figure out what 12% of 40,000 is. However, to really figure out what that multiplier is, what I'm going to do is a little bit of algebra here where I'm going to factor out a 40,000. So this is like reverse distributing. I'm factoring out a 40,000 so that when I do that, when you remove a 40,000 from 40,000, when you divide that out, you're left with a 1. And then when I remove a 40,000 from this product here, I'm still left with the 0.12. And so now what I have is I have 100% of my 40,000, the 1, and 12% of the 40,000, 0.12. And now I subtract the 100% minus the 12%, 1 minus the 0.12. When we take a 1 minus a 0.12, that gives us a 0.88, that's my multiplier. But we did tackle this earlier in the year, so just kind of a little refresher on how we deal with that here. But my new multiplier is, I had 100% minus the 12%, that gives me 88% or 0.88. That's my multiplier. So I can list that off here. And now that I have my A, now that I have my B, I've got my initial value, I've got my multiplier, I can plug those into my formula. This is going to be 40,000 times 0.88 raised to the x. And that x value is measured in time. The y value is the value of the truck in dollars. And we're looking for what is it going to be worth in 7 years. So I'm going to just plug in 40,000. I got 0.88 raised to the 7th. I'm going to pull out my calculator here and take 40,000 times 0.88 raised to the 7th. And that gave me a value of $16,347. Since we're dealing with money, why don't we go all the way out to 2 cents? So, big thing, figuring out what's the starting value, what's our common multiplier, and then once you write that exponential equation, you can use that to figure out what the final value is. All right, one more example here. In this case, I'm just giving you a table. Okay, and the question with this, these are so data points here. We could have thought of this as a geometric sequence, but I want to write, instead of just the equation for the sequence, I'm going to think of it as an exponential function. Looking at this, here are my x values, here are my y values. Hopefully, one of those unknowns in my formula, y equals a times b to the x, one of those unknowns is jumping out at you, and that should be the starting value. Here it is at x equals 0, my y value is 8. That's my starting value. I know that a is equal to 8. So then the question is, how do I find that multiplier? Okay, and what you have to remember, especially when we dealt with sequences, is the multiplier is whatever I multiply by to get from here to here, or from here to here, that I multiply by that b. Sometimes we called it r when we were dealing with like rebound ratios for when we had those bouncing balls. We might have called it something else, but in this case, we're just saying I multiply by b to get from there to there. And so if that's the case, if I take 8 and if I multiply by b to get 12, well, how do I figure out what b is? I've got a very simple equation here. We're just going to divide by 8. So b is going to be 12 divided by 8, which ends up being just 1.5. Okay. Well, what if we had picked a different combination here? Maybe I didn't want to look at the 8 and the 12. What if I looked at the 12 to the 18? It looks like if I start with 12, I'm supposed to multiply by b times b, and that's supposed to give me 18. If I solve this for b, I get 18 over 12. That's equal to b. And hey, look at that. That's also equal to 1.5. So we could have figured it out by looking at the 12 and the 18. Same thing with the 18 and the 27. Okay, did I multiply by b here? However, so we're pretty much done with the problem. But I wanted to give you this example because I wanted to look at this right here. That notice I'm going from x equals 3 up to x equals 5. And for all these other ones, to go from 8 to 12, you multiply by b. To go from 12 to 18, you multiply by b. To go from 18 to 27, you multiply by b. What do I have to do to go from 27 to 60.75? Well, it looks like I made 2 steps, because instead of just going from 1 to 2 and 2 to 3, I'm going from 3, skip 4, and go all the way up to 5. So I jumped twice, essentially. That if I were to write out all these terms here, we could say, here's my term 0, 1, 2. Notice I'm using some geometric sequencing language right now. 3, 4, and 5. To go from here to here, you multiply by b, multiply by b, multiply by b, multiply by b, multiply by b. So times b, times b, times b. Except we made like a double jump here, so that in multiplying by b twice, really to go from 3 to 5, we had to multiply by b times b. We had to multiply by b squared. So we could have thought about it that way, as I'm looking at how did I go from 27 to 60.75, because I'm going from 3 to 5. I had to multiply by b twice. I had to multiply by b squared. So what do I do with that? Well, I take a 27, I multiply by b squared, and that gives me 60.75. If I want to solve for b, let's divide by that 27. So b squared is going to be 60.75 divided by 27. And sure enough, when you take 60.75 divided by 27, you get a 2.25. So that's what b squared is equal to. Oh, if I have a b squared, I'm running out of room here. B squared equals 2.25. If I want to solve for b, how do you undo squaring something? I'm going to square root things. And if I square root both sides, I find that b is, oh, there's that 1.5. So just another way we could have found that b was equal to 1.5. So after all of that, if our job was just to write the equation of this exponential function here, through multiple methods, we found that b was equal to 1.5. So we get an answer of y equals 8 times 1.5 to the x, and there's that. Okay, hopefully these examples are helping you out as you're working through your problems, and certainly let us know with any sorts of questions